So regenerative braking, that is nothing but the concept of motor as a generator, right? So that is what the definition says, energy recovering mechanism. Okay. Uh, so, okay, this point, energy recovering mechanism, this is what simply everyone said, right? So that actually what it is going to do, that is going to completely stop the vehicle? No, it is going to slow down the vehicle, moving vehicle, that is going to slow down actually. There only you can achieve this regenerative braking, first of all, right? While slowing down, you can have a greater continuous input to the motor, which is a kinetic energy. Then that can be converted into electrical energy, which can be stored or which can be immediately utilized. That is the one purpose. So people are thinking that is a brake. That is not the thing here. So now you can imagine what is the problems are also, right? So that is not going to stop immediately. So this is a new technology? No, completely. Where we have seen from the British railways, nothing but before independence, the Britishers who ruled India are given us a system, for a system of transportation, public transportation, that is British railways. In that British railways, the late 19th century or the early of 19th century, okay, late of 18th and early of 19th, there the concept of regenerative brake is came actually, that is implemented in the worldwide actually in the railways. So I have seen that one train which is traveling from Araku Valley to nearby district. Okay, so Araku Valley is on the what we call mountain side. Okay, so while going to Araku, towards Araku, we have to use the power. But when we are coming back, that is just downfall. Understand? So there, that Indian railways, especially these South Central railways, in my observations and my understanding, there we can see this regenerative braking in Indian railway system. Likewise, in most of the places, you can also observe. Right, and that is the thing. We are not aware, but that doesn't mean that is a completely new, right? So the timeline you can see, the 1930s and 1920s, we have implemented this thing in India also. That credit was gone to the British railway system. So there is no record for the achievements in the Indian government thing. That is one thing happened, right? So this is oftenly confused with the dynamic braking. So what I am said is, um, continuously slowing down is one thing and suddenly stopping is one thing. So what is brake and stop? The difference between the brake and stop you can understand here very clearly. And then the similar things you can also imply in the basic mechanical things also. Okay, the drum braking and disc braking. Disc braking is, what does it do? The braking functionality it is reduced, and that is tends to stop the vehicle as fast as that can do. That is what disc brakes, right? So the braking time is reduced, that is the disc brake. And that ABS is etc etc things are again the complex system, right? So this is not the dynamic braking. The regenerative brake is not the dynamic brake. Okay, that is very clear. Similar to that, of course similar. Okay, but not exactly. What is the thing is here in the electrical application dynamic braking, that energy collected from the motor is wasted in the resistors and heat, right? In the regenerative braking, that is the energy collected is utilized immediately or else stored. So you can say that is similar. Yes, from the 20 sorry, not 20, actually in the 2008. Okay, in the 2018, I think everyone knows that KTM bikes in India. So that KTM is the one company who successfully developed one kinetic energy recovery system, KERS. That is what in Formula One on 2009 onwards, that is incorporated. Understand this point. This is very interesting thing, the basic thing, right? These are the companies now implemented the regenerative braking. You can see the Tesla Model 3 is the only one vehicle from Tesla, right? So the amount of collected energy from the regenerative brake system is very less as per the records. Okay, the maximum energy what we have collected is up to the 10 percentage only what we spend on the propulsion system. So that too with lot of difficulty. The regular or average that is also gone for 3 percentage, 4 percentage. So what you have achieved so far, that is different. In the race tracks, that is different, right? For in the daily commute, that is very typical situation for us, right? And after that, just understand this thing. Practical regenerative braking problems and the on-road situation what we have. Okay, the braking is not itself sufficient for the soul, means the self bringing, okay, the what we call stopping, simply, okay, stopping the vehicle, okay, safely bringing a vehicle to stand still, that is one thing here lacked. Okay, what is this thing is doing? If you are on the downfall, understand my part, if you are on the slope and a free fall position, so that is continuous. So the regenerative braking is continuous, but that is not going to stop your vehicle. That you have to understand, right? Slowing it as required to regenerate, that is the thing, concept, simply, right? After that, so it must be used in conjunction with another braking system such as friction based, nothing but again you have to use that hydraulic braking systems in the four wheeler, pad brakes or leg brakes or what we call wrist brakes in the two wheeler. So this is completely not a reliable braking system, first of all, that is one thing, right? After that, the regenerative braking which is comes from the motor is actually to generate the power supply or collect the power supply which is wasted, right? So that effect drops off at lower speeds, right? So when you are in extreme low speed, you cannot generate on the horizontal lines or a horizontal surface when you are driving. So you need to have a inclined position only, that to falls position only, falling on the inclined rolling position, simply from the uh, terminology of this one, wheels. Okay, so cannot bring the vehicle completely to halt, stops quickly. That is what today's current technology lack. So that development part, electronics and power electronics engineers can work here if anyone interested. Okay, so this is the one model. Chevrolet is one company and Volt is one model, EV model, right? That is the one thing which is using, right, still. And before that slide can gives you the best example of who are adapted the technology, but this is the one model which brought that regenerative braking into the picture, actually successful model. Before that, General Motors electric vehicle one from the very olden days, 1990s somewhere, you can see that that is very useless technology, but this is one good technology. Their records are uh, reached, okay, modern records, right? After that, this regenerative braking is nowadays you can see in the Nissan Leaf model also, that is a kind of single down one pedal driving. So uh, A, B, C, accelerator, brake, clutch is the three you can see. But in EVs, which is equipped with regenerative braking, you can go for only single pedal. Understand my point? So if you press the pedal, your vehicle goes forward, right? And if you leave foot on that pedal, right, that is continuously slowing down. Understand my point? If it is in a horizontal position, that vehicle may stops, but longer distance that has to travel unnecessarily. Sometimes that leads to accidents, right? So that problem is included in the one pedal driving, but that is there actually, right? This is the overview for the drawbacks. Still there are drawbacks here actually. So only four left. So current regenerative braking do not immobilize the stationary vehicle. Understand? So this is cannot be used as a vehicle immobilizer. So park brake assistance and handbrake assistance, these kind of functionalities you cannot achieve. First of all, that is inherent property or inherent drawback, you can say, right? After that point, physical locking is required to the vehicle. Obviously the consequence here, for example, prevent vehicles from rolling down on the hills. Understand this point? So but here what happened is the Nissan Leaf model is the one model which is having advanced regenerative braking. When you go on drive up to the hill, right, when you remove your pedal from the accelerator, that helps to roll back, stopping the rollbacks. Okay, that with the help of advanced vehicle control unit as well as rollback mitigation electronic circuit. So this coordination and advanced vehicle control unit, which is designed for only EVs, these things all together put one complex system, right? So that kind of systems you need to achieve actually, right? So that complexity is still there, but somehow someone is achieved, and that is not open source, closed source, nothing but proprietary to one company only, right? R&D functionality can do anyone, individuals also, right? Many road vehicles in the regenerative braking do not require the do not have drive motors. Okay, drive motors on all wheels. You can understand this point. This is self-explanatory, as in a case of two-wheel drive car. Okay, so front wheel or rear wheel. Understand this point. You can have only cheapest vehicles, then front wheel or rear wheel drive. This is the only option. That is where simply this sentence conclude that two wheel drive, right? All wheel drive or 4x4, that is exemptional, right? So this is one case, right? After that, regenerative braking is normally only applicable to wheels with motors. Understood my point? This is nothing but in order to get a somewhat considerable efficiency in the regenerative braking, you need to have the motors on the wheels. Nothing but today's in general quotation we call that as hub motors. So if you are using a mid motor which can support the drive train actually, then there is no good efficiency in the regenerative making. That is the records saying that records are open source. You can download and verify that the chain drive or belt drive or shaft drive, whatever the thing you wanted to use. There is no restrictions, but that is recorded the least efficiencies in the regenerative braking, right? Clear? And after that, regenerative braking effect available is very limited. Understand? When you are continuously driving, right? In Tesla, and not only the Tesla, modern internal combustion vehicles also having that cruise control point. When you are on highway, okay, when you are on a highway, that cruise control is one thing. You enable the cruise control without putting continuous force on the pedal accelerator. This cruise control is able to drive your vehicle on certain speeds, right? Once you press the pedal, that cruise control is disabled and the controls will be falls under manual driving position. So, right, so this is one kind of thing you can understand. Similar to that, this is availability is very limited. So nothing but slowing down of the vehicle is having very limited scope for a up and down journey if you consider, right? That is simple thing. So obviously relying or depending on the regenerative is a foolish idea. First of all, from the realistic parameters of a driving pattern from any corner of the world, if we understand, right? And still mechanical braking is needed for the speed reductions, right? Understand that point. If there is any accident is there and you are relying that Tesla autopilot, right? If that is system not detected, that is going to hit the truck or anything, accident is happened. Just you can understand this is the problem with the Tesla autopilot. Still they are researching, so they are completely come up with new system. Every 30 seconds you need to touch the steering wheel in Tesla, right? So there is no guarantee on the practical implementation of regenerative braking, right? So this is one slide you can understand. This is also another slide where most of the automotive standards are came, right? All the motor related, powertrain related, controller related, and electronics, automotive electronics, and automotive communications, everything is listed here. These are the standards with their numbers actually, right? Broad classification is American Petroleum Institute. They have designed API 541, 546, 547, right? Where these are the things I am actually projected here with respect to the motor only, first of all, right? So squirrel cage induction motor with 375 kilowatt, there 500 HP motor and larger things, that's standards, and 500 kilovolt amperes kVA ratings of the motors. So kW is different and kVA is different. So in AC power supply, the power is itself having again three kinds of power: apparent power, reactive power. Okay, so most of the time we will go for this reactive power, which is kVA, right? This actual power, that is nothing but the horsepower in the mechanical terminology, that is kW, right? So everything IEEE standards, API standards, and the latter this thing you can see here, IEC standards and NEMA. NEMA is the most important standard, which is from early old days also. National Electrical Manufacturers Association. This is actually the US standards. Understood? This is US standards. According to this thing, the starting current of any AC motor must be less than 3 times of the normal operating current values. Understand? The starting current is in the normal times. Just understand that is at about 10 amps. Sorry, normal operation is about 10 amps. Then the starting current is must be less than the 3 times, actually 2.5 or 2.7 or 2.8 is up to 3 is permeable thing. If you made an electric motor, okay, that normally consumes 10 ampere, but for the in starting condition, if that is gone for 5 times or 7 times, so if your motor need to be get and certified used in anywhere in this world, then that is not going to certified. So this kind of operational procedures and etc you need to understand, right? So we are buying motor from China, then what is the standard it doesn't passed? Okay, it doesn't passed any kind of such standard, you can understand. So under wider library, this you can UL standards you can also see in your mobile or laptop adapters, right? So standard for electrical motors. So mobile, if you are seeing that EL standard is nothing but vibration is comes from that is one kind of motor, right? So above all are paid and very widely open source. Okay, open source very widely but paid actually. Nothing but what is the difference here? What I am saying is you have to buy, and that is how that is open. If you see few patents from before 2019, all are closed source, you cannot buy and you don't know how many patents they have and what is the patent related to what, right? But this third edition from the 2018, this Indian standard IS 12615, okay, this is one thing which is completely open source, nothing but free to access for Indian citizens in India. In India, for Indian citizens. If you are outside, okay, and not a Indian citizen, you have to pay, right? Understand? And this standard is related to line operated three phase line power supply, right? For that motors actually. IE code, okay. So this is about the standards and today's motor, and that's it. Anyone has any doubts actually? Yeah. Yes. Hello. Hello. I will wait for the next 5 minutes. I'm open the chat box also. Any doubts from anyone? Yeah. Yes. Yes. What happened? No one is opening mic and asking any questions. Yeah. What? I'm not able to hear your voice properly. Hello.
Hello.
Yeah.
Good evening, sir. This is Ram on this side. I have a doubt.
Can you speak a bit louder?
Yeah. Hello.
Yeah.
Am I audible now?
Now it's okay.
Yeah. So I just like out of curiosity, I have this question.
Hmm.
Like, what is the basic difference between alternator and a DC motor? Like, although they're like both are same in a working manner. So can you please throw some light on this particular topic?
Yeah, yeah. Okay. So alternator, in which context you are referring that alternator? That is in the automotive sector or in any
No,
other
sir. Like,
application?
no, not just only automotive segment. I'm talking. Like,
Okay.
we do have alternator in the vehicle and DC
Yeah.
motor at the same time. So,
Yeah. DC motor, which is in the vehicle, four-wheeler, usually four-wheeler or any similar kind. So the DC motor is used to crank the vehicle crankshaft, self-starting, engine starting, first of all, right? That is motor only, right? The alternator is actually, what does it do? That is going to generate the power supply, okay, to charge the battery and to feed the power supply to the ACs and other what we call comfort related electronic devices in the automotive, and also use it for the lightning and indicators, etc., etc., right? Alternators use it for generators kind of thing. So difference between the generator and alternator is the construction, the output. These are the two things you can see, right?
sure, sir.
uh, right. So generator, there is a simple thing to understand. One can give you the DC, one can give you the AC. Understand?
Yeah, sure, sir.
Yeah, simple. The simple difference.